All right, so we have done practice question 1 for chapter number 12. Here, I'm trying to show you how to do other questions for chapter 12 practice problems. You may need this help to prepare for your final exam or the exam 3. So I'm going into practice problem. So I have already created a video and I have shown how to do this one. And then question number 2 is very similar to one of the homework questions. So I'm not going to go over this question. You can watch my video for homework questions, and then you will be able to do this question. Question 3 is a little different, and it's something new. So let's do question number 3 right now, and then we can move on to question number 4. I would say before going into question 3, you should understand sensitivity analysis. So read this section carefully. So just read every line of sensitivity analysis from your textbook, because question 3 and 4 and even question 1 was actually based on sensitivity analysis. So everything we have to do is not just optimize the solution, but also show how sensitive is the solution. So let's do question number 3. So for such kind of question, we have to formulate our problem pretty well. So our goal is first to formulate the problem, write the objective function, write all the constraints, and then enter everything in Excel. So here I will show you how to formulate the problem, and then we can go into building it in Excel. So our goal is here. So let's read the question first. So the management of Hartman Company is trying to determine the amount of each of the two products to produce over the coming planning period. So they're trying to they have two products and they're trying to determine how much they should produce. And we have given this following information. So there are labor availability, how much labor we have and how labor should be utilized, and how much profitability we can achieve from selling each product. So there are 3 departments, and each of them takes can produce this much product 1 and this much product 2. Oh, this many hours to produce product 1 and this many hours to produce product 2. And the total available hours to department number 1, department A, is 95 hours. And the profit for each product is different. So it's $30 for this and $15 for product number 2. We have to develop a linear programming model for Hartman Company, solve the model to determine the optimal production quantities for product A, for products 1 and products 2. So first thing, we should understand that this is a maximization problem, and we need two factors, two variables, product 1, product 2. So if you know how much we can make product 1, we can call it, for example, X1, and how much we can make product number 2, we can call this X2. So to start, let's say there are 2 products. So X1, I'm giving a name to the units produced for product 1. X2 is the units of product 2 produced. I'm putting up this so we know what are our constraints, what is our objective. So everything has to be clear. And that's why our goal is to first formulate the problem perfectly and then go into Excel and create the problem. So put all the cells together and everything. But let's first create, first put the problem into perspective. Wait a second. All right, so all right, so another thing we can do here is we can put some constraints here. Let's subject to, so I'm putting ST. Well, before going into subject to, we can actually make the function. We are trying to maximize our profit here. And the function is like this. We have some units of X1. So I will say AX1 plus BX2, which technically means that A and B are just placeholders. We will be changing these values to get the optimal answer, to get the maximum profit. And another constraint, now we are putting the constraints. Subject to, there are few constraints. And the best way would be to list all of them in detail here. Nothing will be used in Excel from here except that we create another. So I will create another sheet where I will put everything in a table so I can use it. But this is for me to understand the problem. So when you see this question, this type of question exam, try to formulate the problem. So I'm just trying to formulate the problem. I will solve it later. So what are the constraints? So try to understand the constraints here. The constraints are, we have these many hours per unit. So the department one, when they manufacture this product, they take 1 hour for product one and 0.35 hours for product two. And the total hours they have is 95 hours. So what I can say for X1 is 1. So I'm not putting anything here, but I'll put X1 plus 0.35 X2. This has to be less than and equal to 95. So this is for department A. I can put here department A. Another constraint here is X2. Sorry, I will put here 0.30 X1, 0.20 of X2, and this has to be less than equal to 36. And this is for department B. So these are the constraints on production of each department. The third one is 0.20 X1 plus 0.50 X2. And we have to just be less than and equal to this much. And this is for department number 3. This is for department C. And these are our total constraints. There's a one more constraint which we usually don't talk about, but it's necessary and it's common, which I haven't maybe talked about before, but there's always a constraint that X1 and X2 are greater than or equal to 0. So we have to make something. It's not like we can just we cannot go negative. We can make X1 0 or X2 0. They should be 0 or above, but we cannot be negative. So this is a general constraint and it's already been by default applied in the solver. Once we have this, we can actually, once we have the problem formulated, it will be easier for us to go into Excel and then do everything. So what I would do here, I will actually go to a new worksheet and then create the problem. So I will copy this data and put it here. Okay, next I will put my model Next, I have to also put my profit. So the profit is 30 for this department per unit. And there's an extra column here. I can just delete this column. And there's also an extra column here. And this just makes more sense to me. And then this one. And this one gives us a profit of 15. Okay, everything looks good. We can go into our model. So we are making a model, and first thing we'll put parameters. Now we have two values. So whenever you get you are at this stage, you have to think about, okay, what are the parameters? Parameters are the changing values. So we can change x1, x2. This is in our control, and we can change these. We cannot change what department can produce. We cannot change what's their hourly hours required. What is the total hours? What is the total profit? We cannot change it. We can only change these two values. So we should put them in our model. So product one and our product two, we are trying to maximize these two numbers. For example, right now, I will just put here placeholder things. I'm just putting 10, 10. These are just placeholders. In the model, we will be changing these, updating these by taking care of all the constraints. All right, next step would be to put all the constraints. And in this, it's actually not that hard, but one thing we should take care of, we should not go above these hours, and we should maximize our profit as much as we can, or the production. So we haven't made the production cell, which we have to maximize. We haven't really put the constraints for each department. So let's put the constraints for each department, A, B, and C. And we can say how many hours been used from each department. This is in our hand. We can shuffle how much we need from each department. It just depends on how much we produce from each department technically, and how many we do it here. So this is the number of units per hour. This is how many you will do in an hour, and how many you do. So this is the number, like we are doing 10 from department A, and the hours per unit is 1 per hour. If I do this one, I can produce 1 and extra. Okay, so I can produce more from product 2 from the same department. So I will do here some product, and in the sum product, I will be doing these ones. So this is for department A. So I have to go this way, right? I have to go this way, and then how much I produce. Okay, so this constraint, or how many hours I have used, depends how many I produce from department A, or how much I use from department A, while it depends on the number. So if I change these numbers, and both products can be made from the single department. For example, if I put here 5, this number changes. Same thing we can do for for department number B and C. We can just see how many hours are needed to produce, and then once I have that, I can just see how many I'm producing. To do this, I can just drag this down, but I have to make this one constant. So I can make B12 and C12 constant by pressing F4 on my PC. I can go like this. So this time, these cells have been selected, and the same 2 cells are from here. Next, is for department number C, and same two cells. All right, so this is how much hours we are using from each department. Just for clarity, I can actually write here hours per unit, and I can just make it merge and center. So I just merge this. So these are hours per unit, how much time it takes to produce one unit. And we have to be careful. We don't want to go above this. So that's a constraint on this one. All right, so let's go into the solver. Now, once we have put all of this, we can go into the solver. Oh, before going into the solver, we should also take out the profit. We haven't really made the formula for the profit. So profit is always pretty simple. We can just make some product of this number and this number. Okay, so just multiply product one with product one production, multiply product two with the product two production. So the profit of product two with the product two production. And this one. Right now, for example, our profit is 300. If I go 95 or 100, it goes to really high amount. If I go 10, I cannot go. So this one goes 500. I cannot go above 95. So just for testing. So I'm testing. So this is okay. This is okay. This is, it goes 93.5. Other ones are okay, but maybe I'm not optimal. So this solution is not probably optimal. Also, if I increase this one, it goes 107, and this also goes out. This is only within the limit. So that's why we need to find an optimal solution. So these hours should always be less than these hours. Pretty straightforward. Other things will be in their place. So what we have to be careful is actually just these hours. This is the only constraint. They have to be less than these hours by changing the values of these and maximizing this number. All right, so let's go to data. Let's go to solver. So B19, we have our set objective. We want to maximize by changing values in these two cells. Our objective is that these values should be less than or equal to these values. Press OK. Go to simplex linear programming problem. And this one is the one I was talking about, that the variables cannot go negative. So it's checked by default. Leave it like that and then press solve. Once you solve, you will get the answers. Press sensitivity so that if there are more questions, we can answer them. So let's produce this one. All right, so let's enter the number, and they're saying enter 2 decimal places. We can easily make this 2 decimal just like this. So it's perfectly 2 decimal. And the next question is, in computing the profit contributions per unit, management does not deduct labor cost. So they don't deduct labor cost because they are considered fixed for the upcoming planning period. Okay, so we don't see any labor cost here. We have just given hours, and we have been how much can be produced, how much time it takes to produce one unit, and what is the profit. So we have not been given a labor cost because management thinks that the labor cost is just a fixed cost. It doesn't matter. There is no additional cost for producing additional unit, but it just takes more time. However, suppose the overtime can be scheduled, and some of the departments. So some departments can do overtime. Which department would you recommend scheduling for overtime? All right, to answer such thing, we have to go into sensitivity analysis, and we have to see if we have to find some department which has the highest shadow price. So let's go to the sensitivity report. The first table here is the variables changing table. So we are saying how much we can change the variables. And for example, these two are the final variables, and we are showing how much is allowable increase or decrease. So how much we can allow some kind of an increase or decrease so that the objective is still the same. The overall optimization doesn't go away. So there is some flexibility. But for this question, we have to focus here because we are changing or we are adding another constraint, or we are saying, how about if we have the overtime, where should we add? Since the cost of the overtime is not, the labor cost is fixed, which department we should add the overtime? We should add the overtime where we are getting the maximum profit. And shadow price actually shows how much you can get the profit if you produce one more unit. So here, the shadow price for this one, department A, is 27.9. For department B is 0, and for C, it's 10. So based on the shadow price, we can say that if we add another unit, or if we spend one more hour on producing a unit, we will get the $27 of profit. So we should add the overtime in department A. Okay. What is the upper limit, or would you be willing to pay per hour of overtime in the department you recommend? So think about it. This is the shadow price, and this is the additional profit we will be getting if we add the overtime. So how much we should pay for the overtime so that we are still at the break even? So the maximum I can pay is actually this amount, because if I pay more than this, I will be losing money. So I will never pay more than 27.9, 27.91. This is maximum I can pay for the overtime in department A. So let's submit this work first and see what's the outcome. Okay, the next part is, now suppose that 10, 6, and 8 hours of overtime may be scheduled in department A, B, and C. Now we are putting another constraint. It's a type of a constraint or a condition which adds overtime into the 3 departments. And the cost per hour of overtime is $18 in department A, 22.50 in department B, and 12.12 in department C. Formulate a linear programming model that can be used to determine the optimal production quantities if overtime is made available. What are the optimal production quantities, and what is the revised total contribution to profit? All right. So this is our original model. What we have to do, we have to include the overtime in this one. I will leave this one as is and make a duplicate copy of this one. Make a copy. Okay, so we have another copy, and then I will name this one as overtime. So this one is our original. All right, so the next step is to change this problem so that we can add overtime in it. First, we have now 3 more facts for the 3 departments. So I will put here overtime hours because they have given us 10, 6, and 8 hours. For department A, I have 10 hours. For this one, I have 8. And this one, I have 8 again. And the cost of per hour. So these are the cost and normal timing. And now we need the cost, OT cost per hour. And then OT cost per hour is 18 for this one, 22.5 for this one, and 12 for this one. All right. Once we have these two things, now we have to change this constraint problem. So we were using these hours, but now we can also use overtime hours. And what we can do here is we can create another problem, overtime used. Why? Because we have to, so here we actually did hours used. So we said this is the total hours, but we will use this much. We always do this. We have original hours, and then we say how much of that limit we are actually going to use. So the same thing, we have these hours, and then we are saying how much we are going to use, and we can change that. It doesn't matter if we don't have to use all of them, we can keep changing them. So what I would do, I'll just put here some placeholders. Okay, and another thing we should be careful here is that now we have total hours used, OT used, and our available hours are this much. Okay. How about if we take a difference between what we use in our from the regular hours and the overtime hours and take a difference? That would be actual our now the pre-overtime hours. So why don't we take a difference, and I will explain you more and you will understand why we are doing this. So regular hour use would be this minus this one. So just hang on with me and then you will see the difference. We will use this in formulating the problem. And then our total profit does not just depends on the profit and the hours and units. Our profit also depends on the overtime hours and their cost. So always cost has to be subtracted from the profit. So this is the total profit. And if I go above labor hours, I have to subtract that because that's a cost. So some product, I will do again some product, and then I have this one. These are my costs, and it depends on how much I use this. All right. It totally depends on my cost, how many hours I use this. So it depends how much these values are changing, how many hours I go above, and these cannot go above this one. Okay. All right. So let's go into the solver and solve this problem. So our solver, we have same, we want to maximize this by changing values in these cells, B12 to C12, these cells. Also, we have to be careful here. Now we have to say we can also change the values of these ones because it depends on our overtime hours usage, how much we use, so we can change these. Okay, so what I would do, I will add here in my constraints or in my changing values, I can say, okay, these values are changing. So I added, these can change, production numbers can change, and the overtime hours used. And then I'll remove this one just for now and then add two brand new constraints. The first constraint is like that. How does, well, the first constraint is that we have to see these hours. Oh, sorry, this is totally wrong. Set objective function to this one. And we are trying to add these. So the first thing we have to do, we have to say, okay, these hours should not be greater than these hours. So this is a point we have to be careful that these hours cannot go above these hours. Okay, so the first constraint I'm putting here is that hours, regular hours used, um, because this has been kind of total hours, but these are the regular hours used. So I will say, okay, regular hours cannot go above the available hours. We have to put a constraint on them. Okay. So to add here, I will do these cells has to be less than equal to these cells. Okay. So once we have this, next we have to take care of the overtime hours, and they should not also increase than the maximum overtime allowed. Okay. So I will add another one. So I'm saying these hours and not go above actually these hours. And these are the two constraints we have to just add. C15, C17, E3, E5. E3 is this one. This looks correct. And then we have D15, D17, which are D15, okay, which are these cells. They still have to be less than the available hours. Okay, so let's solve the problem. And we will again print out the sensitivity report. So this is the sensitivity report number 2. This is the overtime. So this is our new outcome. So let's enter these values. 67.44. What is the total profit? 3230.58. Oh, nearest whole number. Okay, 3230. How much overtime do you recommend using each department? And we have to make our, so this is the overtime we recommend for each department. So just note that why I did this, because once we remove the constraint on the first one, so it's going above. So this is like a total hours. If I don't limit, If I don't subtract the 2, I will have a problem. So first we had a constraint on these cells, like these cells has to be less than this. No, I removed it. I just made this one as total hours. So for example, here, this is a sum product of B3. B3 is this cell into the B12 into this number, okay? So this is the hours used without the overtime. This is the overtime, and these are the difference. Oh, these are the total hours used. This is the overtime, and this is the without overtime regular hours used. And they cannot go above this. So here I have 10, 1.91, and then 0. What is the increase in the total contribution to the profit if overtime is used? So we have to compare this number with actually the original one. So let's copy this, and so we have this number, and we can do this one, subtract this one. So this is the, all right. Let's see. All right, so this is how we do this sort of question. I will make another video for question number 4. And I'm also planning to put this on the Blackboard. So I will submit this file on Blackboard so you can use it for your analysis. Practice. Problem number 3. And this is chapter 12. All right, so I will make another short video for question number 4.